Welcome back to Do It Yourself Python series. And if you are here for the first time, please go through my previous short videos on this topic. And this video is the part 2 of Linear Regression Basics video. So in this example, I just wanted to show you a data set which we will be using to create a model and using linear regression method and also predict some values. Okay, so let's go ahead and see what we have in this data set. This data set has two columns. One is the weekday number and the second one is orders. The weekday number represents 1, 2, 3, 4, 5, 6, 7, and each number represents a weekday like Monday, Tuesday, Wednesday, and also each day has a total number of orders, and in this case I have 12 on the first day and 36 on the third and 84 on 7th. And if you notice this data set, the same set like 1 to 7 is repeated a couple of times. In fact, it is actually repeated 7 times. Just keep that in mind. Okay, so this is the data set we are looking at and we'll be using it in our exercise. I just wanted to show you the same file. In a notepad. This is what exactly in the CSv format, comma delimited format in this case, we are seeing the same data what we are seeing in the data set here. Okay, so in order to use this data set and in order to use the linear regression method and create a model, so what we're going to use is that we're going to use Azure Data Studio. Yeah, this is something new I wanted to introduce in this topic, but if you're not familiar and if you still want to use an existing Python based notebook tool, you can still go ahead and use a tool called Jupyter. When you install Anaconda, it actually installs a couple of tools. One is the Jupyter, the other one is a Spider, right? And this Jupyter is actually a browser based tool, and when you launch it you can actually see that it is running at the local host, and it has some the folders are already set up. But the main use of this Jupyter notebook is you will be able to write code on the web page, and you can actually execute it directly from the web page and get the result there itself. At the same time, you can also add your additional markdown, something like I can just put some h1 and test h1, and then if you just run it, just see that there is a markdown there. So mainly these notebooks are used to give you a presentation, or maybe used mainly in the training. So I'm going to use the same feature in this video, but instead of using this Jupyter which is part of the Anaconda installation, I wanted to use another tool called Azure Data Studio, and I'll put the link in the description. You can download this Azure Data Studio, which is free, and again this is from the Microsoft. So let me go ahead and open the Azure Data Studio, and this is exactly Azure Data Studio, and if you are very familiar with the Visual Studio Code, it looks exactly the same but with some additional features, right? So if you want to create a new notebook, you just go to the file and start a new notebook, and in this notebook it is so powerful that you can actually pick a kernel, like if you want to just write all the SQL code and execute them and then see the results on the same notebook, you can choose the SQL. But for our exercise, I'm choosing Python 3. Like when you select Python 3, and automatically what happens is it actually shows you where exactly it is running. So this is right now running in the local host, and very similar to what we just saw from the Jupyter notebook. Like if you go back to this, and if you notice that Jupyter is also running at this local host. Right now, instead of Jupyter, I'm using this Azure Data Studio. Right? Once you have the Azure Data Studio up and running, and assuming that you already created a new notebook, so the very first thing, I'm just adding some statements into this notebook. Just see the markdown is basically I'm using a very simple HTML tags to give an idea on what exactly this exercise is. And I'm also trying to test whether my Python is working properly or not. This is what I do most of the time. I just put a variable called message and initialize with some text and try to print it. See that this is the whole web page, right? But the beauty of this notebook is you can actually execute that particular statement and get the results here. Let's change this one to something else. And if you rerun it again and just see that there's a text, the new text automatically appeared here. This is very powerful. Behind the scenes, it is actually talking to the kernel. It is executing these Python scripts statements and giving the results back. So that is the first part, to quickly check that. And I added some other markdown here. And then in this, the second section, what I'm doing here is that I'm trying to import pandas, which we needed for the data frame, and the NumPy to do any array processing. And I'm also using another module called SQL Learn, and I'm just importing the pre-processing part of that SQL Learn module. And also in the SQL Learn, I'm also importing linear model. This is where our focus is, and I'm importing that as a linear regression. And then also I'm using the SQL model selection, and I'm also importing the K4. I'll discuss this K4 and SQL modules in detail in later videos. But let's focus on this. And also I'm importing this matplotlib pyplot, which is Python plot, and I'm just initializing it as PLT. And this line %matplotlib inline is required for this notebook. It's actually not required when you're writing this Python code directly in a Visual Studio Code, or maybe directly using Visual Studio, or maybe using Spider. You don't need actually all this line, but for this purpose I'll discuss all these import statement and this section in detail later, right? So let's focus on the very first step here. So the data frame, I'm using pandas, and I declared a variable here called data frame, and I'm just using this PD, which is nothing but pandas, and using this read CSv file. Right now my CSv file is located here in C drive and the Pizzapy folder, and this is the same CSv file I was showing you some time back. So now after this reading is confirmed, means basically no errors, and when you can just run that and see whether it's working or not. Let's change this into something called CSv XYZ, just to see whether it is executing and then actually throwing the error. So when you try to execute, and you can see that it is trying to resolve the file name, but it was unable to, and then it gave you all the error messages you need to debug and then figure out what exactly is going on. So anyway, let's go back to this, the correct file name, execute it. So no errors, which means it was able to read the CSv file. And the next step is, and normally what, when you're doing modeling, or when you're trying to figure out what exactly the data looks like, you can go back to the CSv file and you can look at all the values. But in Python, at the data frame level, you have a small utility called head, and then if you run that, you can just get the very first few lines of from the data set. The good thing about this is that you can see the column names here, just to make sure that everything is good, and these are the actual values, and it also has an index number attached to each record. We won't be using that in this example, but just keep that in mind. So like any data science experiment, you want to know more about the data, right, before even jumping into any analysis or any kind of experiment. And you also have another simple feature, means utility called hist. It just shows the histogram of the data and how actually data is distributed. And again, it just takes the sample data and show you that, so that you know whether the data is properly distributed or whether you can really work with the data or not. This is just to give an idea, not required, but let's execute that and see that it is actually showing you histogram for both columns. Another thing is that like in the previous video, I was showing you exactly the real use of this the scatter plot, right? And you can achieve that using this PLT, which is, if you go back, it is actually the PLT is coming from this matplotlib and pyplot. So I'm using that lab module PLT, and I'm using a method called scatter, and then I'm passing this data frame, right? And in this data frame, I'm just passing the very first column, which is weekday number, and also I'm passing the second column as orders. So this particular scatter takes, in this example, two inputs. One is what exactly we wanted to show in X and what we wanted to show in the orders column. So if you run this command, and you should be able to see a scatter plot here printed within this notebook. And to give you the context, let's go back to our Google Sheet, and if I just select all these values, two columns, all the values, and try to insert a chart, and again I just selected here chart type as scatter chart, and it has the same values here, means it's the same number of rows, and you can see that this is also actually printed as scatter chart right in this Google Sheets. And the same thing you will be seeing when this is printed within the notebook. There is no difference. One thing we didn't do in this particular section is we just plotted this scatter chart. That's all. We did not add any trend line, and we are not able to see anything, any r-squared value here or any equation. So we can show all that information, but for this example, let's leave it at this scatter chart, right? So go back to that Google Sheet again, and now try to add a trend line by going into the series, trend line, data labels, and error bars, and also try to show the r-square value and also the equation. So the r-square value here, it is showing as 1, which means it's a perfect model. It's like 100% you can predict using this particular model. Please keep this in mind when we are actually trying to write exactly the entire code in the Azure Data Studio notebook. I'm switching back to the notebook again, but this time we're going to write some interesting code to see what exactly the values we'll get by doing modeling here. So here I'm just declaring a variable called ind variable, which is basically an independent variable which is in this x-axis. In our case, this is the weekday number, and I'm initializing that variable using PD pandas data frame, and already we have a data frame here. If you go back, this is the data frame I'm referring to, but I'm actually initializing only the very first column to this independent variable, which is x in our case. And there is a dependent variable, the orders. I'm initializing the orders here so that we can use these two variables to create our in the model. So I'm declaring a variable here called LR model, and which is initialized with this class called Linear Regression. If you go back to our import statements, you can see that we are actually importing it, and we are giving a name here as a linear regression. So I'm using the same here, but this time I'm actually declaring another array called empty array called R values. This is exactly we wanted to see. If I run linear regression on this data for a number iterations, and then I just wanted to see what are the actual R squared values coming back. But there is another lab module which I need to discuss in detail, which I'll be doing in the next video. But here it is, this I declared a variable called cross validation variable, and I'm using this module, this library called kfold. And if you notice that I'm just passing two variables. There are other variables you can pass. We can discuss that in detail later. But the most important thing is that there is a variable called n splits. I'm setting that n splits as 7. I'll explain what exactly that 7 means. And also right now I'm using this shuffle as true, but I'm going to change that to false for this particular step right now. And then this is again a for loop for I, whereas it can be 0. Then I'm using this train data and test data. There are two variables I'm using it, and then I'm initializing these two variables when I'm actually going iterating through this cross validation variable. Cross validation variable is basically, right now it has some values inside like n split 7 and shuffle false, but I'm passing this independent variable and dependent variable, and I'm just splitting that. Now I'm iterating through that data set, right? So as part of the iteration, the very for loop, the very first step is I'm initializing I'm using this LR model.fit function, and I'm passing the independent variable as a train data, and also a dependent variable as a train data. Again, I'll discuss this in each and every variable and what exactly they mean and how they represent data in detail in a later video. So I'm using the LR model fit here, passing this train data, and then for the dependent variable as train data. And now what I'm doing is that I'm just training my model, right? I'm trying to fit my model by the trained data. But now I'm going to apply that the trained data, that whatever the model I got, I'm going to apply that on actually a test data. So this is the same variable here. So now what I'm doing is that I'm trying to fit my model using the train data, but at the same time, once it is done, I'm trying to score using that model using test data. So whatever score I'm getting, I'm just taking that value and storing it in a variable called score. That is nothing but r squared value, and I'm storing that value score into this list called r values, and this will go on for a number of iterations, and that is exactly decided by this, the number of splits, right? And then I'm actually once my model is trying to fit, and then using that model trying to score and storing that score into this r values, and finally I'll have a list of r squared values based on the number of iterations I performed on this data set. Here it says 7 now, so let's go ahead and run this, and it finished executing this entire script, and but it is just showing you an array of values, like if you count them 1 2 3 4 5 6 7. So now here at this point, what is exactly this 7? So how I came up with this 7? If you go back to this data set again, if you notice that I was explaining this data set is actually repeated 7 times, means 7 weeks worth of data. So when I say split this data set into 7, it is trying to split this entire 49 records into 7 sets, which is nothing but a week's worth of data. Let's go back to Azure Notebook again. Let's change this to something called 2. Now just run it. Still it is 1 and 1. R squared value is 1. That means it is only taking the first 2 sets and applying this linear regression on that, and giving us the r squared values after executing that script, like trying to fit and trying to score and giving the r squared value. But again, if I change this into 3, let's see what happens. Not much, other than it is just giving us 3 r square values, and every r square value in this scenario is 1. And we know that when r square value is 1, it is a very good model. But if you notice that in the second argument here, it's called shuffle. Right now it is set to false, which indicates that the data is actually used as it is. Whatever you're seeing in that CSv file, whatever the order you're seeing in the CSv file, nothing is shuffled. But let's change that to true. This is forcing this, the k-fold is actually forcing the data set to shuffle. But so now they're not in the order, but it retains the same record and values. Nothing is interchanged. Only thing is the order of the records are changed. It is shuffled right now. So if you execute it now, you're still seeing the same values here. So no matter what exactly you're trying to do, whether you're trying to shuffle the data or you're not shuffling the data, no matter how many splits you take, the model is perfect. Like, it is giving r squared value as 1, which indicates that it is perfect. So now this is how you actually do your model. You'll try to fit and then score and see whether you're happy with the r square value or not. If you're not, you're going to run this iteration number of times. It all depends on how you organize your data at this point and what exactly you're looking at. And if you are familiar with my previous video, and in that video I said that There will be outliers, you need to watch for it, but in this case our data set is very straightforward and the data set itself is perfect. So the R square values are perfect when it is trying to fit the model. So the next step is, let's say that you are now happy with this model, because this model has a very good the R values, R square values, and you are very happy with those numbers. Like 1 means it's 100% accurate. So let's use that model to predict some values, right? So this code is basically, I'm just creating a list of my predictions, means the values I want to use it for the prediction. So this is basically in y-axis values, and let's say I want to predict what exactly a value looks like 12. So when I say 12, what I was referring to is the weekday 12. Even though technically we don't have a weekday number 12, but what I'm trying to show you is that these x values are 1, 2, 3, 4, 7, and I'm trying to predict what is the y value for 12, right? And if you notice that the data itself is giving you some idea on how these values are set up. This is 12 and then increased by 2 times, like in this case it's 24, and 12 multiplied by 3 is 36, 12 multiplied by 5 is 60, 12 multiplied by 7 is 84, and the value we are expecting here, if you just following this pattern, 12 multiplied by 12, right? So let's do that. 12 multiplied by 12 is my y value. That's a predicted value by looking at the pattern here and by looking at the model, because model is exactly one which indicates that 100% accurate. So go back to that list, and it's here. Once you have the model and once you are happy with your model, you can use the model right now. See, I'm using this LR model, which is nothing but LR model here, fit, and we're trying to score the same object I'm using here. Now I'm having a predicted values, a separate variable, and I'm just passing this list into this predict method, and then I'm storing those predicted values back into this list. The last statement is I'm just trying to print the list here. So okay, let's run this one and see that our predicted value is 144. Let's go ahead and add some more values here. I'm trying to predict y for x value, in this case 3, and I'm also trying to predict y value for 6. And when you try to run this, and you can see these values are right now 12 multiplied by 12 is 144, 3 multiplied by 12 36, and 6 multiplied by 12 is 72. Let's change few things. I'm going to use this 7 splits, which are basically all 49 records, 7 each, and then I'm going to use this true for the shuffle, right? Let's run this, and if you notice that again our R squared values are 1 in all the scenarios, in the test and then the train data, right? Using the test and train data. But if you run this now, after that everything looks good. There's nothing, no big change here. So I'm going to say 3 splits, run it, and then run this again. No change. 3, and I'm going to say false. Run it again, no change. Run all the cells and see that there is no change. So I hope you understand the very basics on how to use linear regression method to create your model, and how to run a test on that particular data set using this model, linear regression model. And by splitting the data into the number of slices you want, and also you can control whether you want to reshuffle the data within the data set or not. And here this is a very simple for loop. You can actually do it manually, individually, one by one, but you are using a for loop, and you're taking only a small amount of data from that data set as your trained data set. Like, you're training the model with a very few number of records, and then you're getting the R squared value. At the same time, you're trying to fit that using the trained data. And then once the model is familiar, like now with this trained data, and you're trying to use the same model to score using test data, whatever the data is remained in the data set, to see whether those values are matching, your predictions are actually matching or not. So that's what exactly this loop is. And at the same time, for every test you're running, you're trying to get the R value when you're trying to score it. And these R values are very important, and as I explained in the previous video, this is where everything comes down to. But this is again a very simple linear regression, not complicated, and the data is also very straightforward. But once you start looking at the different data patterns, and then you may have to adjust these values, and you may have to settle for some R squared value which you are comfortable. But I hope this simple example gave you enough idea on what you can do with this Python, and then how you look at the data and how you apply the linear regression and create a model, and ultimately use the predict method to validate again. This is the real-time one, right? So validate your model and then compare these values with the actual data set. Thanks for watching. I'll include all the links to these documents, and I'll also upload this data set and this notebook to the GitHub project, so you can download and you can straight away you can start working or maybe running these examples.